experiment, that is a small experiment to show, to see how the rays will be converging in the concave and convex mirrors. Is it clear? So first for this we need to take a foam. Either you can take a foam, sponge, or else anything that which will be elastic in nature. Is it clear? So now on this what I am doing is I am placing the pins. Is it clear? So I am placing the pins which are in a straight line. Is it clear? So these points are perpendicular to the plane of the sponge. That means this sponge, if we consider this as a mirror, so these points are nothing but considered as normal at these points. Is it clear? So now when you incident a ray on this points, then this will be the normal and the reflected ray will be coming from this point itself. Is it clear? So now if we consider this as a mirror. So see, now suppose I am bending the sponge like this. Is it clear? So now what is the, it is a curved shape. That means it looks like a spear. Is it clear? So now if you consider this part will be convex. Is it clear? And this part, the inside one, will be a concave. See, now I have placed the pins over the convex side. So see, the pins are being diverse. That means they are pointing in different directions. Can we, if you imagine and draw a line, can we get the point of intersection of all these pins? No, you don't get. Why? Because the rays which are reflected from the convex side will be diverging in nature. And now if you bend the sponge towards inside, see, like this. Is it clear? So now you see, when you bend like this, so this becomes a concave surface. Is it clear? See, now here the pins have been come together. Is it clear? So now if you draw an image, you can see that at some point these all rays will meet at a point. Is it clear? So that point is nothing but what? Converging of the light rays. Is it clear? So from this we can clear that the convex side the rays will be diverging and from concave side the rays will be converging in nature.